Why does the rope turn exactly 50 or 60 times a second?
You know how your car's engine feels most efficient at a certain speed on the highway? Every time you flip a switch, you're tapping into something massive. An invisible rhythm, a single, synchronized heartbeat that connects an entire continent, from the biggest power plant right down to the phone in your hand. Today, we're going to tune into that pulse and figure out why its timing is maybe the single most important rule in our entire modern world.
Just think about that for a second. How is it possible that millions of different things, lights, factories, your laptop, all draw power from the same system across thousands of miles, all at the same time, without the whole thing just collapsing? What's the one rule that keeps all of it in perfect sync? Well, it isn't some supercomputer. It's actually a surprisingly simple and incredibly strict physical law.
The answer is an invisible pulse. It's a constant, perfectly timed beat, and right now, the entire country is essentially dancing to it. And this beat, it isn't a suggestion. It is the absolute law of our electrical world.
So, to really get this, we have to talk about the grid's heartbeat. Now, engineers call it frequency, but honestly, let's just use a simpler way to picture what's actually going on.
I want you to imagine that the entire power grid is one single, enormous jump rope that stretches across the entire continent. Every power plant, every single home, every business, they're all connected to this one rope, all at the same time. The speed that the rope is turning, well, that's frequency. It's the beat, it's the rhythm, and it's not just a guideline. It is an absolute law that everything connected to that rope has to follow, no exceptions.
And the rules of this game are really simple, but they are super strict. First, the giant power plants, they're the ones providing the muscle to turn the rope. That's our supply. Second, every home, every factory, every light bulb, they all have to jump over that rope in perfect time. That's the demand. And the one unbreakable rule, the effort of turning the rope has to perfectly match the energy of everyone jumping at every single moment.
This constant turning, this rhythmic up and down pulse of the rope, is basically what engineers mean when they say alternating current, or AC. So unlike the steady flow you get from a battery, the power on the grid literally pulses back and forth. That back and forth motion is the beat.
Okay, but why that specific rhythm? Why does the rope turn exactly 50 or 60 times a second? Seems a little random, right? Well, the reason is basically a historical echo, a decision made way back at the dawn of the electrical age.
It all goes back to the very first machines we built to turn this electrical rope on a massive scale: steam turbines. These were, and in a lot of places, still are, the huge, powerful engines that generate most of our electricity.
Now, these gigantic turbines have a natural sweet spot. You know how your car's engine feels most efficient at a certain speed on the highway? Same idea. These machines were just most stable and powerful when they were spinning at either 3,000 or 3,600 revolutions per minute. Running them faster or slower was just a waste of fuel.
So the engineers did the most logical thing. They took that perfect mechanical speed, say 3,600 RPM, and they hooked it up to the simplest kind of generator you can build. And it just so happens that that exact combination naturally creates an electrical rhythm of exactly 60 pulses a second. If they used the 3,000 RPM turbines, they got 50 pulses. It wasn't some random choice. It was just the most efficient way to do it with the technology they had.
And that early decision basically split the world in two. Different regions built their entire electrical systems around one of these two magic numbers. The Americas went with 60 beats per second, while Europe, Africa, and most of Asia standardized on 50. And here's the thing, once you've built a jump rope the size of a continent, you can't just decide to change the speed one day.
So we've established the beat is sacred. But what actually happens if it stumbles? What are the real-world consequences when the rhythm of the grid gets thrown off, even just a tiny, tiny bit?
Let's use a real-world example. Imagine it's the hottest day of the year. All across a major city, millions of people get home from work at roughly the same time and crank on their air conditioners. What does that do to our giant jump rope?
Well, the effect is immediate. Suddenly, you have millions more people jumping, which makes the rope feel incredibly heavy to the power plants that are trying to turn it. So the generators physically start to slow down. The rhythm, the frequency, drops from a perfect 50 Hz to, say, 49.8.
That tiny change is a massive red alert. Before the generators literally start to tear themselves apart from the strain, automated safety switches kick in, and they intentionally cut power to certain areas. A blackout isn't really a failure. It's a desperate safety maneuver to stop the entire jump rope from getting tangled up and crashing the whole system. For about 100 years, we got really good at this balancing act. But today, keeping that beat perfectly steady is becoming a much bigger challenge. The very nature of our jump rope is changing. Think about it this way. The old grid was turned by these enormous heavy steam turbines. Their sheer physical mass, their inertia, acted like a giant heavy flywheel turning the rope. It was hard to speed up, but more importantly, it was really hard to slow down. The rhythm was just naturally stable. The new grid, though, relies a lot more on solar and wind. They don't have these huge spinning parts, they use power electronics to create the rhythm. It's kind of like we replace that giant heavy flywheel with a tiny but powerful motor. It can react fast, but it's also twitchy. The rhythm is now much easier to disrupt.
So what that really means is our modern grid is lighter, it's more fragile, and it's way less forgiving when things get out of balance. Keeping that perfect 50 or 60 beats per second now requires split-second, computer-speed reactions and a much smarter way of managing this constant dance.
So if you take away just one single thing from all of this, let it be this one unbreakable rule that governs our entire electrical world.
The power grid isn't just a collection of wires and poles. It's a single, continent-sized synchronized machine. And frequency, well, that's its heartbeat. It tells us if the whole system is healthy and in sync, or if it's in trouble. Every single component, from the largest nuclear plant right down to the charger in your wall, has to dance to the exact same beat at the exact same time. There is absolutely zero room for error. It's this beautiful, kind of terrifying, and totally invisible symphony that's running our entire world.
If this helps the power grid finally make sense to you, you'll probably enjoy the other explanations we have on this channel, where we explore the hidden systems that run our world.